In order to then solve this and figure out where the tangent slope is 0, we solved f prime of x. So first that means we have to find the derivative equals to 0. So I set that derivative then equal to 0, and I'm then solving that equation. Now notice it's got x squared and x in it, so I'm thinking factoring. And if I'm going to make my factoring job a whole lot easier, I'm going to notice that I can divide every term by 6 at the start and do that. Because then factoring this is a heck of a lot easier. So we factor it down, x minus 5, x minus 8, therefore x equals 5 and 8. But we're not done yet. Because you notice that this is actually asking for the points. So both x and y coordinates of the points where the tangent is horizontal. So how do we find the y coordinates? We do need to plug it in, but usually the question that comes up is, do I plug it into the original or into the derivative? Think about what we're trying to find here. We're trying to find the coordinate on the graph. That's what f of x tells us. It tells us the actual location of every point. F prime of x, that's the derivative. That's the slope at that point. We already know the slope is 0. That's what we just found, because we were trying to figure out what makes the slope equal 0. We want to know what's the y coordinate. Well, that means f of x. So, take 5, plug it in for x in the original function. Take 8, plug it in for x in the original function, and those will be our two y coordinates. When you go to plug them in, pay attention to your order of operations when you plug the 5 in and the 8 in. When you do that work, if you've done your order of operations correctly, this is what you get for each of the terms. And then you go ahead and do the addition and subtraction. So we get these as our two values. F of 5 equals 471. Therefore, we have the point 5, 471. F of 8 equals 444. Hence the point 8, 444. And then we're done. That's what this problem asked for. We gave the coordinates. We're done. Now, visually speaking, what are we really seeing? If we go back to the graph, those 2 points we found are the coordinates of those 2 points where those dots are shown there. And you notice that if I actually drew in the tangent lines at those 2 points, yes, they would be horizontal tangent lines there. I'd like you to go ahead and practice this process now. Go ahead and please find the points where the tangent to this function is horizontal. All right, so once we've gotten to this point, we factored it, we solved it, we figured out what x equals, and we got to plug it back in to find the y coordinates. Because this one, notice this actually says find the points, so that means we got to find the coordinates of the points. Remember that when you plug it back in, you're plugging it back into the original, not into the derivative function. And so when you do that, you should end up with 8, negative 49, and 415. Order you list them in, doesn't matter, as long as you got the same x with the same y and all that stuff. Let's do one last one then. Please go ahead and find the x values of the horizontal tangents in this problem. Once we found the derivative and then we factored out the 10 that can actually come out of every single term, then it's a matter of factoring that quadratic that is left inside of the parentheses. Now, in order to factor this, it's not that nice, pretty x squared type where all we got to do is just add to the middle number, multiply to the last number. We got to do a little bit of work. And what that work looks like is going to depend on what method you used. Now, some of you learned like that airplane method, stuff like that. I use grouping method. And so I start by doing 15 times the negative 77, that is a times c, and we get a negative 1155. And then I have to find the two numbers that add to negative 34 and multiply to negative 1155. Okay? And so, that gives me 15x squared plus 21x minus 55x minus 77. Then With the grouping method, we then factor out of the first two terms anything we can, and then we factor out of the last two terms anything we can there as well. And so we end up with a 3x factored out of the first two. That leaves me with 5x plus 7. And then out of the last ones, I factor out a negative 11, which leaves me again with 5x plus 7. Notice that inside the parentheses is the same. That's good. That's what we want. And so it factors down to be 5x plus 7 times 3x minus 11. The 10 is still hanging out front. We're still solving this set equal to 0. And so then, in order to finish solving it out from there, we set each parenthesis individually equal to 0. And when you do that, you should end up with answers of 11/3 and negative 7/5. Yes, you could turn them into mixed numbers. Yes, you could turn them into decimals. But fractions are just fine.